Hello, today we're here to talk about the Ports site, the Ports Future project Ohio University's been involved in since about 2010. And we're talking about the Portsmouth site, which is located in Piketon, Ohio, which is about 3,777 acres located in Piketon. And we're talking about the actually transforming that former DOE facility into what we call an integrated energy system. So today's presentation is the focus about the integrated energy system. What is an integrated energy system? My name is Benjamin Cross. I'm a resident, executive and resident here at the Ohio University, and I've been a consultant to the Voinovich School for what an integrated energy system is. Today, here's the outline of the presentation. Is to talk about the definition, what is an IES, what is the premise, what's the basis behind an IES, and I want to talk a little bit also about closed loop manufacturing, which we want to include in the part of the IES we want to put at the Portsmouth site, and also talk about process heat applications and usage that we also want to make as a part of the Ports IES complex, and then we want to show you sort of what the IES complex is about, and then also talk about what are the benefits of an IES concept, what are the challenges that got to be faced, and then I'll provide you a summary. So let's look at first what an integrated energy system is. Because we always like to look at definitions for what an integrated energy system is. And here's the definition that basically DOE has. And you can see that's a fairly complex one. It says 2 or more energy resources are utilized as inputs to 2 or more physically coupled subsystems to produce 1 or more energy commodities as outputs. As you can see, that's a little bit of a complicated technical definition. A more simpler definition is multiple energy resources combined together to produce 1 or more energy-related products. Now, IES system is really not a technology, but it's an integrated approach to how you apply technologies. And what I like to call it is a systems of systems approach to how you actually integrate systems together to actually form an integrated system to actually where it can be more efficient and more cost-effective to actually use. But the definition I really like to work with the local community with, as far as the definition for economic developers and other people about what an integrated energy system is, really think about it as co-locating and combining and interconnecting and networking energy producers and with energy end users. That's where we want to be able to combine not just the energy producers, but the energy end users together to when you actually cost effectively integrate the energy producers, but also tie them in with the energy users to be where they're used together and have them integrated together. Now, what is the IES systems comes by a lot of other names. In the past, and what the technical people like to call is cogeneration. You probably heard this term. It's been around particularly since about the mid-1970s when the United States was in an energy crisis. It became very popular to have cogeneration. Cogeneration is usually thought of as a single energy source producing 2 energy commodities. And in other words, it's more recently used in this as combined heat and power, that you may see a lot of times in technical papers and also in newspapers about combined heating power systems. And that's really talking about where you have natural gas, coal, oil, or biomass to produce a process heat. And typically that's for a chemical process. And when you're making this for a chemical process, as you make that heat, you say, well, I could use that heat for other purposes as well. And so I can use sort of the waste heat from my chemical process to generate electricity. So actually using process heat for chemical processes and also to generate electricity, that's what a lot of companies are doing. And in Ohio here, Solvay Polymers and Piketon Polymers, that's exactly what they did over in Marietta, Ohio. But now also, as we move forward, there's people look at what they call hybrid energy systems. And of course, hybrid energy systems, you can probably relate to those most with like a Toyota Prius or hybrid cars, where you have an internal combustion engine and you have an electrical motor as well that drives the wheels. And so you have a combination of both electrical and internal combustion engine to actually drive the vehicle. And so that's another definition to have, but still most people when they think of hybrid systems, just like they do on the Prius, they think of combining just 2 systems together, even though in the definition of hybrid energy system, it can actually be multiple systems that can be tied together. And the more term that actually people are starting to use now is combined energy systems. And combined energy systems was coined by a guy at MIT, Dr. Forsberg, and that combined energy systems really sort of defines exactly really what it is. That's combining energy systems and integrating them together. But I like the definition that they use. The Chinese use one called polygeneration. If you look at a lot of literature about hybrid energy systems or combined energy systems, and if you look at polygeneration, you'll see where a lot of researchers from China has used the word polygeneration, and I personally like that term very well as well. Here's an example. Since about 2006, China has really been aggressive about building these polygeneration facilities. They have to do it more out of necessity than anything else because they have limited energy resources available, and also with their manufacturing things, they want to tie those closer together. And this happens to be a picture of a facility of a coal chemical recycling economy demonstration park, as they call it. And they have where they really are utilizing coal in multiple ways to make value-added products. So they have their energy and their manufacturing combined together at this particular facility. And so China has about 5 or 6 of these facilities that they put online since about 2006. Now, what's the premises or the basis behind integrated energy system? Well, it's the whole is worth more than the parts. And what does that mean? Where you take the word synergy, synergy is basically, it comes from the systems approach. That's where you hear that sometimes say 2 + 2 = 4, but this is where they say 2 + 2 = 5. Because working together, being integrated together, the whole was a lot bigger than what the parts that make it up. Utilizing this also is utilizing smart systems that we hear a lot about today to create smart solutions. This is where you have sensors and items that can actually detect other things, and with the Internet of Things going on as well, you can connect things together to come up with solutions that in the past you could not come up with. So these are trying to get smart systems to find smart solutions. Now, one thing with integrated energy systems, one of the premise behind it as well, you want to base things upon a value. And that depends on what do you value coming out of the project. Of course, most people think of either making more profit or being able to save cost. But there's a lot of things you can actually value. As an engineer, typically we want to have thermal efficiency. We like to have high efficiency when we make something so we get the most back out of what we put into it. And that's the same thing from an economic situation as well. You want to be able, for the amount of money you put in, to get the maximum amount of money you can out of it. So the higher efficiency you're that way, or a higher cost, of higher rate of return. And the other thing you can have is value. You can have reliability, where it's going to be available, and also that it's resilient, that it's a robust system, that if something happens, goes wrong with it, that you can be able to put it back online, that it's not going to be taken out easily at all. And then, of course, with the environmental issues we face in America, and people talking about climate change and other things that's taking place, we want to look about low emissions, like how we have an environmental impact, so how you can have waste minimalization to take place. So that could be your value for why you're trying to have this system integrated together. So you want it integrated together so you can produce lower emissions and less waste. And then, of course, again, we mentioned before about the cost. Now, most people want to shoot for the lowest cost, and that seems what drives people to have the lowest cost. But sometimes you want acceptable costs. Like, for instance, if you want to be able to have better environment, you may have to pay a little bit more. So maybe if you pay just a slightly bit more, you can adjust the system. It might cost a little more, but you're going to reap the benefits of having it be better, much better for the environment. Again, you can pick whatever one of these value propositions, and then you can adjust the system based on that because it's all working together. But now the definition I really want you to remember for this, what we call for the ports integration complex that we want to put over Portsmouth, is really just fundamentally remember it's the synergistic integration of all the above energy strategy. About everybody has agreed from a political standpoint from both parties, and about everybody believes we should be using an all the above energy approach. However, above energy approach, when it's not working together, can be detrimental. If you're just going to try to depend on just wind, just solar, just hydro, just nuclear, just coal, or natural gas, having just a single approach is not going to get you the effective system you need to have. The idea here is actually to have where you synergistically integrate all these above that are economically available for the region. So the definition I want you to sort of look at the best here for what the premise of this, the IES is, for a synergistic integration of all the above strategy. Now let's look at how industry is done today. Industry today does things what I call a linear system. You bring natural resources in, you bring it into the factory, you make products, and part of those products is waste, because that's the product that you don't sell. That's the product that's not going to make you money. That is the part that you just basically dispose of. And that is basically how almost all of our industry is set up here in the United States, be this a power plant or be this any type of chemical factory or a production factory, that it brings in resources, you make a product, and you throw away waste. And that's a very linear type system. What we want to move towards is a more circular system, where you actually have that where you see in this picture, that you're actually bringing in the waste from one product to going into the next plant to make another product. So here you may have you're producing a product, but you have a byproduct that you normally would throw away as a waste. You actually take that waste, and that becomes a feedstock, what's called a feedstock, or a material, and you add maybe some additional natural resources, and you make other products that are what we call value-added products that you can market, or marketable products that you can sell. And the idea is to daisy chain these together sort of in a circular fashion to where there is virtually no waste. The goal is actually to have zero waste from all this. And this is what's called closed loop manufacturing. And for some of the more technical people, the fancy term for this is industrial symbiosis. This is getting the industries to actually work together and actually minimize the environmental impact that they have, but also, from their perspective, is to maximize their profit and their income. Now, one other thing is we look to be able to have on some of the integrated energy system is really better utilizing the process heat. And that's by looking at the process heat applications. And here's an example of a list of some applications that you can do at various different temperature levels. Starting in the upper right-hand corner, you can see that's in the 800 to 1,000 degrees C range. And that's where you can actually, like say, make hydrogen from water, where you do water splitting, because water is H2O. You can split the hydrogen from the oxygen atoms and actually generate hydrogen that way. There's a way most hydrogen is generated today now is actually do what's called, here you see the second level, is called steam methane reforming. And that's how hydrogen is made today at about all of our refineries and anybody that's making hydrogen. They're actually converting natural gas and transforming it and reforming it to split off the hydrogen atoms, and that's how that's done. And you can see where cogeneration of electricity and steam, that's done between the 350 to 800 degree temperatures. And then you see these other processes as you step on down that you can also, like petroleum refinery. And then also you have water purification and ethanol concentration facilities that's more down in the 80 to 200 degree range. But the idea here is actually what we want to do is actually utilize the heat at each one of these steps. Because once you utilize the heat at the oven, see, if you're exhausting at 800 degrees, then you can go down to the next level and use that heat at the next level. And as that process heat, as that working fluid cools down, you actually could go down to the next level and utilize it there. The goal here would actually be where now you see power plants and stuff built with cooling towers, or plants using cooling towers, and to cool the process heat fluid down. We want to now be able to actually use that process heat by co-locating another facility there, another manufacturing facility, another process, to be able to actually utilize that heat. So we want to utilize that heat basically all the way back down to ambient temperatures. And here's another little graphic to show at the Portsmouth site what we would like to do. And I'm showing the Portsmouth site right here in the middle. That's sort of the yellow and the darkest red right here in the center. And that's the 1,200 acres, what we call inside Perimeter Road, which is about a 1,200 acre portion of the port site over in Piketon. And that's where you would have the high temperature, the high hazard, the high security, the high dollar investment facilities located within that area. That's where the high investment, high dollar facilities that DOE have are already there. We just want to take the facilities from there and transform them to these new facilities and put those kind of facilities there. And that's where you would make like electricity, you make hydrogen, you make ammonia production to make fertilizers and other things. You can have a refinery, and that means not just an oil refinery, it could be a natural gas refinery or a biomass refinery. The refinery there is used in a generic term. Or metal extractions and treatment can be done at those high temperatures. And as you utilize the temperatures, what the waste heat from that facility would go to the next layer out, and it would help drive those chemical facilities and processing facilities. That's the next layer out. And then so on and so forth till you go all the way out to the outer side to where you go out here to the lower temperatures, when those are temperatures probably closer to like around 80 degrees C or less. And that's where you can do anaerobic digestion. You could use district heating you can have for the facilities and buildings that you have there. I think one of the unique ones is to have grow houses and greenhouses. Grow houses would be a great area to be able to grow food indoor. You hear a lot about vertical farming these days, to be able to grow indoors. Well, you know, here in Ohio it gets cold in the wintertime, and we need to be able to have the heat to be able to grow year-round. There's also going to be fish hatcheries. So you can, but the goal here is actually use the heat that's generated use it for every level all the way out till it comes basically back to atmospheric temperature. So there's a lot of products, as you can see, a lot of different processes that can be done by utilizing the heat. And by if you co-locate these facilities sort of in a concentric circles, as you can imagine, going out from the center being the hottest to the outside being the coolest, is be able to use that heat at all different levels. Instead of having cooling towers and sending the water vapor up into the atmosphere, we want to utilize that temperature to make some kind of value product. So what does the Ports IES complex look like? Here's sort of an overall graphic. You see from the upper left-hand corner, you can actually bring in natural gas, which we're co-located here by the Marcellus Shale, the Utica Shale, which is one of the largest gas reserves in the world. From what I understand, it is the largest, Marcellus Shale is the largest gas reserve in the world. And you'd be able to bring that gas or biomass or municipal solid waste from our various cities, like from Columbus or Cleveland, other major cities. Also, chipped tires can be be used for a heat source. And then at some point in the future, you could actually, if we have advanced nuclear reactors, whatever the next generation reactors that come out, that actually, they could also actually be the heat source. Anyway, you take a heat source and then you make a process heat. And that's typically steam. It doesn't have to be steam. It could be a molten salt. It could be other working fluids that we like to say technically. But let's just say this is steam for now. And you can make electricity that would go power the grid. And then you can also make hydrogen. Well, what's unique about making hydrogen, you can make it, like I said now, from steam methane reforming. And this diagram shows initially, because that's how it's done today, is taking natural gas to make hydrogen. And once you make hydrogen, there's all kinds of products that you can make from it. As you can see here, you can make methanol, you can make ammonia, you can use it in a refinery to hydrogenate hydrocarbons to make gasolines and fuels and alcohols. You can also use that hydrogen in foods to make vegetable oils like your margarines and your shortening. And of course, there's a lot of other reasons that you can use hydrogen. People are talking about fuel cells. You can provide hydrogen to fuel cells as well. But as you can see down this list, there's a lot of different products that can be made by these fundamental, that comes originally just by having hydrogen, because hydrogen is a very important element in the manufacturing of so many different products. And also, as you give off you see coming off the hydrogen production of the steam methane reformer in this case, you get CO2. Well, a lot of people talk about CO2 going back to the atmosphere. No, the concept we want to do is actually recycle the CO2 and use that CO2 to make other products that you like your beverages, Coca-Cola. You know, you got carbonic acid that you put in. You put CO2 in for carbonated drinks, and for other chemical products that you make, you can utilize that CO2 to repurpose that CO2 versus letting it go to the atmosphere. So this is sort of an overview of what the IES complex at Portsmouth will look like. And there's obviously more. This goes much more technical detail than this one, but that's sort of a quick overview. Now, what is the potential benefits of an IES? Well, one of the key things I like to let people know is it's really effective resource management. That's what we should all be doing. How we were put on this earth, how do we most effectively use the resources that we have? Of course, a lot of industries want to look at that as how they can make the most profit or how they can be the most cost saving. But it's really about how can we be most effective with the resources that we have available, how to best utilize those resources. That gives us a higher, in the case of an integrated energy system, what is the highest overall energy usage efficiency that we could have? Which I mentioned before, typically engineers think of that as thermal efficiency. How you can be most thermal efficient. That could be also how we can be most cost effective or how we can be most environmentally efficient as well. Of course, one other thing benefit out of this is actually better utilization of capital equipment and lower operating expenses. If you have systems integrated together, they can share a lot of things that actually lowers that cost. And how is that done? Well, shared resources. You can share infrastructure, buildings and facilities and pipelines. You can share personnel, maintenance crews, administrative personnel. There's a lot of things that if you co-locate facilities together, you can actually integrate the resources that you use. Some of the other, you can also integrate the processes themselves. And here is very key, especially the ones that have common processes. Like if you actually have a biomass refinery or a natural gas refinery, an oil refinery, and you're making gasoline, heating fuel, or jet fuel, or some kind of lubricant, it may start off as a different carbon feedstock, but it all ends up being the same product. Well, somewhere along the line, it becomes common to what it takes to produce it the rest of the way out. Because out in, say, even the pipeline that carries it to its final destination or takes it away from the factory, all that is a common, so you don't have them build. As I mentioned earlier, in the linear system, you build it separately, and each company builds its own system. Here, they'd actually share the common processes that they have and be able to reduce their cost, and by sharing these processes together. Of course, one of the key areas here too is, as a benefit, is reduced emissions, and particularly of CO2. By having these facilities co-located, just the transportation between them and other activities, we can really save a lot on CO2. And as we mentioned, as we move more to a circular economy, the waste product of one plant becomes the feedstock of the next plant. So ideally, we want to put enough plants in place where virtually there's no waste coming out the tail end. And of course, the key is, as you know, we import a lot of oil in the United States. Most people don't know, we still import 10.1 million barrels per day of oil in the United States. We need to be able to use more of our domestic resources like natural gas and biomass that we have here in the United States to make our products out of. And integrated energy systems allows us to do this, so we actually have the more cost-effective approach to be able to do that. With the low price of oil, it inhibits you being able to do natural gas or biomass or turning other biomass feedstocks, because typically it needs about a $70 per barrel cost to be able to do that. And with now price of oil below $70, that makes it a little bit difficult for these other companies to be able to compete with petroleum. And also, of course, really what's the benefit is you have industry collaboration and co-location. What's very important in the IES system, what the real benefit is, of course, you got to get the people working together, but by them being located together, this helps create jobs and more jobs. And also, when you start making products that's not only wanted, but the products that are needed, like energy products we have to have. We need jet fuel to fly our airplanes, we have fuels to drive our cars, and make electricity to run our computers and our other systems and our manufacturing facilities. When you have those co-located together, then that means those jobs will not be moved somewhere else. We cannot generate electricity here and sell somewhere else, just like China cannot sell its electricity. It has to be built and manufactured right here. So the more things we actually produce right here, close by, especially in the Piketon area, that would mean, as much as we can do that, we have what's called non-exportable jobs. Now, what are some of the challenges that are faced on the IES? As you can probably imagine, of course, one of the things I sort of hinted to before is you got to have co-location of industries. You got to have multiple organizations actually working together, which means they got to plan together how they're going to do this. They just can't just sort of all of a sudden decide they want to go build something real quick. They got to plan this out, what it's going to take. And I always like to remind people, if you want to get systems to be organized together, integrated together, you first must get people to be able to integrate together. So you got to get the people of these various industries, get them talking to each other, and then that way they can discuss it from a policy and from a business standpoint, and then they can let their engineers work about how you best integrate these systems to be cost effective and do the different value propositions that whatever they have agreed upon to be able to accomplish. Of course, as you might guess, if you start locating these large type of facilities together, there's a very large capital investment. So we're talking really projects that are in the billions of dollars. And we're not talking a few $100 million to do these types of projects. They're in the billion-dollar class facilities. And of course, when you start bringing a lot of large capital investment together, you start talking about investment protection. So you want to be able to locate these facilities at a place where it's secure to do so. And that's one of the reasons why the Piketon site, the port site over in Piketon, is a very good site. It's already set up for with a very high security systems over there. And so from an investment protection standpoint, for people who's invested a lot of money, they want to be able to make sure those systems are going to be very secure. Because we know in today's world, places where there's a high dollar investment, where there's a lot of money being made from in the United States or any other country as far as that goes, that those are potential targets for terrorists. And so those need to be hardened type facilities. Those need to be very secure facilities when you start locating like chemical plants and power plants together. Now, as you can probably imagine, it requires a very unique site. And these types of sites were typically are called mega sites, where these integrated energy systems are located, like the ones in China. They call these mega sites. And mega sites means usually mega dollars or multi-billion-dollar facility. And usually talking about a minimum of $3 billion, but most of the facilities we're talking about probably are more in the $25 to $50 billion range for investment that it's going to take to build some of these facilities that we'd like to do at Piketon. But it doesn't start off there. I'm talking about when it's completed. But you got to be near energy and natural resources. So you need to be close to if you're going to be producing energy and utilizing energy, you need to be close to those resources. You want to have excellent infrastructure. And what does that mean? Well, it means you need to have heavy industrial infrastructure and support services that are nearby or right there. Very good, strong electric transmission lines need to be there. And transportation. And you see the one I put down here as well, underneath transportation, I listed resource and product pipelines. Very key as well to be able to bring your feedstock material into the site. Like say if it's natural gas, you will need to have pipelines to bring the natural gas in, but also the products you produce, the heating oil, the jet fuel, the gasoline, other products that can actually be pumped through pipelines so you don't have roads or have to go over the road or go over it by train. Of course, we want a good rail and highway transportation system as well. But the pipelines, having pipelines there is also very critical. Of course, the state of Ohio has a very good pipeline system. And of course, if we want to do this at Portsmouth, we need to make sure it has a good pipeline system there. In fact, if you look at the Portsmouth site, it meets all these requirements very well. Probably, if anything that's lacking is a little bit is on the pipelines. But that's something that needs to be dealt with here in the future. Now, just in summary, again, the IES is not a new concept or a technology. So it's not a new concept at all. It's not a technology. I already gave you some examples of what it's been called before. But it's an integrated approach for applying technologies. Again, it's taking a systems of systems approach that's really what I like to call focus on a comprehensive synergistic integration. Where we're really looking how we actually totally put everything together to maximize the benefit of this. Where we're trying to leave no stone unturned. We're trying to look at every aspect of how you integrate it together. Of course, to do that as well, you need to make sure its flexibility is there and be able to do that as well so you can bring other systems in so you're not just dependent on one system. You want to have them connected together, but you also want them to be able to operate both dependently and independently in case one was to go down. You don't want it to have a detrimental effect on the other parts of the system. But also, it's an opportunity, as mentioned before, to actually optimize efficiency. And of course, that means from a corporation standpoint, to help minimize their cost, and from an environmental standpoint, it's help minimize the impact. And I just want to say, particularly, is that the port site is very well suited to hold an IES complex, to especially have a synergistic integration combined in with closed-loop manufacturing, not just to produce energy there. That site used a lot of electricity, has a very high electrical grid at that site. But it's also going to be able to produce energy where it actually put electricity back on the grid at that site, but also co-locate the other manufacturers there that can take the natural resources from the region and be able to utilize those and do that in a daisy chain fashion, closed loop system, be able to produce the maximum amount of products and create the maximum amount of jobs for the region. Now the last slide I want to show you here is really this port's reindustrialization. This is sort of like an impact statement. I won't go over it in detail. Obviously the port shows up here in the center. Obviously a facility like this will have a major impact on the port site itself, just like when the port site was created by the Department of Energy back in the 1950s to be a gaseous diffusion site to enrich uranium. This will have a lot of industries located, and so they'll be the center or the hub of where the main activities that take place. But we want this to have tentacles throughout the entire community. And obviously in the community, we want to make a difference in the workforce, obviously, in the technologies and environment, and in the whole industry as well by how a new way of actually, how should we really do things with next generation technology, and how do we actually integrate those together. But we think this can have a major impact not only on the state of Ohio, obviously through like increased tax revenues and businesses that can be created here, but also utilize the resources in the Appalachian area that we've been blessed with here that typically are moved away from here, that we want to add the value here. We want to take the natural gas and actually make products here with it. Just like we also want to be able to repurpose coal and make other manufactured products out of utilizing coal and out of wood products. Is take the products that are here in Appalachia, and we really want to give people hope here in the Appalachian area to be able to move forward. And of course, from a national perspective, this is a U.S. government site. We want to convert this site from being now a federal liability where $1 million roughly a day is being spent to where it can be a facility where multi-million dollars a day of income can be made, which would create a lot of jobs and put people to work and have a big impact to be able to show how you turn this federal liability into a regional economic asset that can be utilized not only by the community, but set the example how you repurpose other federal facilities, but also be an example how you can do this worldwide in other areas of the world that can actually benefit by integrating their energy systems together and with closed loop manufacturing. Thank you very much.